Hello friends, welcome to my channel dataTech. My name is Mrityunjay Singh and today we are going to discuss on Hive, one of the component of Hadoop ecosystem. Let us start. Today's agenda is what is Hive, history of Hive, Hive architecture, Hive job execution flow, features of Hive, and in the last I will show you examples, demo part. What is Hive? Hive is an open source data warehouse system for querying of large data system in the Hadoop platform. It uses HDFS for storage and MapReduce for execution on the cluster. Basically, Hive is a wrapper on MapReduce jobs. When you submit Hive query, it converts into MapReduce jobs. Hive doesn't have any storage system, so it relies on HDFS cluster. History of Hive. It was originated at Facebook. Facebook data was exploding exponentially and they don't have enough developers to write MapReduce jobs. Also, writing a MapReduce job is very challenging. So in 2007, Facebook came with new tool which was Hive and became very famous. Now we'll talk about Hive architecture. There are three parts of Hive architecture: Hive client, Hive services, Hive storage and compute. Hive supports applications using drivers for communications. Clients are categorized into Hive Thrift client, Hive JDBC client, Hive ODBC client. Hive Thrift client. For Thrift-based application, Hive provides Thrift client to communicate with Hive. Hive JDBC driver. It is used to establish a connection between Hive and Java application. So Hive provides a JDBC driver. Third one is ODBC driver. It allows the application that supports ODBC protocol to connect to Hive. Now we'll talk about Hive services. Hive client integration can be performed through Hive services. If a customer wishes to perform any operation related to Hive operation, they must contact Hive services. Hive CLI, command line interface. This is a standard shell provided by Hive where you can execute Hive queries and enter commands directly. Hive web interface. It also offers a web-based GUI to execute Hive queries and commands. Hive server. Hive server enables clients to execute queries against the Hive. It allows multiple clients to submit requests to Hive and retrieves the final results. Hive driver. It receives the query statements submitted by the user through the command shell. It creates the session handles for the query and sends the query to the compiler to generate execution plan. Metastore. It is a central repository that stores the metadata information about the structure of tables and partitions, including column type information. Execution engine. Execution engine validates the plan. Plan contains DAG of MapReduce jobs or tasks that has to be executed on the Hadoop cluster. It sends the DAG to Hadoop cluster where it actually gets executed and the results again sent back to the execution engine. The third component is Hive storage and compute. Hive services such as Metastore, file system, job client in turn communicates with Hive storage. Metadata information is stored in Hive meta storage database. Query outputs are stored in Hadoop cluster on HDFS. Now we'll move to the next, that is the execution flow in Hive. The first step is execute query. User interface or CLI submits the query to the driver. Next step is driver passes the query to the compiler for generating the execution plan. Compiler sends the metadata request to the Metastore. Step number 4, send metadata. Metastore sends the metadata to the compiler. Compiler then generates the execution plan, that is nothing but a DAG, directed acyclic graph. Send plan. Compiler then sends the generated execution plan to the driver. Step number 6, driver sends the execution plan to the execution engine. Execution engine then sends these stages of DAG to the appropriate components, mapper or reducer. Once the output gets generated, it is then written to the HDFS temporary file. These files are then used to provide data to the subsequent MapReduce stages of the plan. Sends result. Execution engine reads temporary files directly from HDFS. Driver then sends results to the client. So this is the overall steps when you submit a query in Hive. Something more about Hive. Hive is a data warehouse infrastructure built on top of Hadoop. It is case insensitive, similar to RDBS. It doesn't support transactions. It is not developed for OLTP. It is developed for analytics. Schema on read versus schema on write. In RDBS, tables schema is enforced at data load time. Hive, on the other hand, doesn't verify the data when it is loaded, but rather when a query is issued. This is called schema on read. Pros and cons. Hive is a supplement of Hadoop to bridge the gap between low-level interface and SQL. Support of ODBC, JDBC, which enables connectivity with BI and ETL tools. It supports table-level partitioning, bucketing, cons. Hive SQL is not 100% ANSI compliant SQL. No support for update and delete. Hive queries contain high latency. Now we'll move to the demo part. We'll show the practicals. We'll go to the Hadoop cluster. We'll go to the Hive prompt. Now we will start the demo part. Here I will show some examples like how to create a table, how to load the data. When you drop a table, what happens? Again, tables are two types, managed tables, external tables. First, we will go to the Hive prompt. Prompt is there. I have created a database for this demo. To see the database, we have a command show databases. The database name is project.db. Use this database. Use project.db. Show tables. Currently there is no tables. Now I will create managed tables. That is managed by Hive. The one of the types of tables. I have already command. We'll copy from here. Go to the prompt. Before that, we will go to the browser where you will see. We'll go to the folder user, Hive, warehouse. Inside, I have created database project.db. So I am inside the project.db. There is no folder, there is no data, nothing is there. Now we will execute it. Execute this command. Table is created. Sort tables. Implied table is created. Now we will go to the browser and we will see, we'll refresh it. See, the implied folder is created. Right now nothing is there because we have not loaded the data. Now come to the prompt. We will see what is the, we will describe this table basically. Describe formatted employee. Here you can see location is user Hive warehouse project.db employee and the type is managed table. We have other information here also. You can see all those things here. Now we will load the data. To load the data, we will load data. We have already a input file from where we will load it. Go to the prompt, paste it here. We have data inside the home sdadmin employee.txt from where we will load our table. We are Hadoop sdadmin. We will say this is our input file. We are going to load this data into our table. Great, data is loaded. Say select star from employee. Data is loaded here. We'll go to the browser and we'll see here, we'll refresh employee. Earlier employee had node folders. Now see under employee, the file employee.txt which was loaded is here now. Now what will happen if you drop this table? We'll say it here. Drop table employee. got dropped. So tables. There is no table inside the project DB database. We'll come to the browser part and we'll see here. See what is it? Part doesn't exist. See here inside there is the folder dropped, and at the same time file also get dropped. So what we understand here, in the case of managed tables, when you drop a table, schema as well as data got dropped. Now we'll talk about external table. We'll create external table, we will load the data, and at the same time we'll drop it and see what will happen when the external table get dropped. I have command create external table. We have to, this keyword is there, external. Paste. So what you are doing here? We are creating an external table and storing as a text file. Location is user sdadmin department dupt. There is no folder right now. We'll show this path also, user sdadmin. Go to the browser. User your user sdadmin, and there is no folder like department. Now we will create external table. So tables. Table got created, department. We'll again describe this table. Describe formatted department. See here, the location is sdadmin department, table type is external table. Now we'll go to browser and we will refresh it. See, the department got created, but there is no data inside here as we have not loaded it. Now we are going to load it. We have already commands to load it, the load data, and we have also file input file from where we are going to load it. Come here, the prompt, paste it. So from where we are going to load it? Home sdadmin department.txt. We'll see that also. Okay. This data we are going to load it. Enter it. Yes, it is loaded. Great. We'll see it. Select star from department. That is got loaded. Now we'll go to the prompt. We'll see it. We'll refresh it. Here, see, the department.txt is present inside the department folder. These are the block ID and block pool ID. These are our information for any file. What is the size like that? Now we will, so now we'll drop it and we'll see what will happen. So tables, right on department table is there. We're going to drop it. Drop table department. So tables. Table got dropped. So there is now no schema. But what happens with the file? Well, let me rephrase it. It is still there. Okay, it is still there. Department folder is there. Inside department.txt file is there. So what we can include in the case of external table, when you drop, schema get dropped, but file data remains there. But in the case of internal, that is the managed table, when you drop a table, data as well as schema get dropped. So I have completed the demo part. So guys, I'm going to end my today's session. If you like it, please press the like button and subscribe my channel to watch my upcoming sessions. Thank you for watching.